Fine, everyone. Perfect. So today we are going to learn about the hardness of water. So as a routine thing, you guys would be going through all of this. Tell me, what do you know about the hardness of water? Right. Go ahead and tell me whatever you know about hardness of the water.
Sir, it is
Yes.
caused due to presence of calcium and magnesium salts, sir.
Okay. So the dissolved calcium and magnesium ions, right? You need to be really specific in this. Why? Because if you are getting insoluble thing, like if I'll ask you, my dear, uh, is calcium carbonate one of the uh, uh, problems of hardness, or we are okay with calcium carbonate? So answer is we are okay with calcium carbonate. It won't cause any hardness. Hardness is created when we have dissolved calcium and magnesium ion. Okay, so what is the consequence of this hard water? I mean, how it is different from the normal water?
It's
Water,
not useful, sir.
sorry,
It's not useful for daily purposes.
like,
Laundry, boilers, even
right,
for us also, sir. For
for
soap.
us also, for us also.
Yes, sir. In soap, for soap case.
Not give that.
Right, right. Not give lather, right. Okay. So yes, you guys told very rightly that hard water in the practical life creates more problem actually. Like one of the biggest problem is hard water prevents lather formation. Guys, please mute it. From soap, right? So which indirectly creates problem in cleaning. So what is soap, guys? If you might be aware with, that is a long chain fatty acid, right? The sodium salt of long chain fatty acid. That's what the general. This is long chain, like sodium stearate. There are many such molecules. So long chain fatty acid, sodium salt of long chain fatty acid is soap, right? This is soap, right? This is nothing but general representation of soap. Now what happens because of the presence of calcium ion or magnesium ion, they are going to form the precipitate. And if they will form PPT, my dear, the cleaning action will not be there. So basically, calcium plus 2 and magnesium plus 2 forms PPT with precipitate with soap, right? So missile formation does not take place properly. And my dear, unless missile formation takes place, the cleaning action will not be very great. Just to, fetch your curiosity, I will tell you what is missile. Just for that, otherwise you don't require right now at this stage, right? So what is missile? Whenever we add, these long chain fatty acid salt, sodium salt of that. So what happens, as you can see very clearly, that there is a negative charge on the carbon. And this R group, as you know, that R group, which is alkyl group, which is carbon, which is almost non-polar, right? A carbon chain is a non-polar thing. Whereas if you look at this part, this is polar. This is non-polar. So what happens that this non-polar end does not dissolve, rather it is present on the surface. So if I'll show you somehow like this, suppose if it is a representation, right? Suppose it is a representation like this. And so what happens that long chain is mostly on the surface, and inside water, the COO minus portion is actually present. Means the polar part or the ionic part is actually dissolved inside the water. The rest part is actually. But if you keep on doing that, what will happen? After a certain concentration, what will happen? That these will accumulate in a very nice way. I will tell you. They will accumulate like this. Please understand, I am not drawing everything on scale. So basically, you can see the negative part is exposed outward, and this is nothing but water, right? So how does the cleaning phenomena takes place? Actually, suppose some dirt is there on the clothes, and we are trying to. So what happens? This non-polar dirt or greasy substance or oily substance, they also have this organic molecule right on there in that. So what happens? This non-polar end used to dissolve that non-polar end. So suppose if it is a grease, so the non-polar end will be present inside like this, and outside it is exposed. So when you are going to, just stir the mixture, or you are just trying to, wash the cloth. So in that process, it used to take out these greasy substance, and here the grease is trapped inside, you can say, and outside they are all negative. So they got dissolved. So that's how the whole cleaning process takes place. This particular form is known as missile, right? Missile. Anyway, so I was talking about that this prevents missile formation because it is directly forming precipitate. So at the end, it will be settled. So we don't want the interference of the calcium ion and magnesium ion. Does hard water do we need to worry about the other ion like sodium ion, potassium ion? Do we need to worry about that?
No.
Answer is no, because you know that most of the salts of the sodium ion is soluble, right? Alkali metal, most of the salts are soluble. So you can see that sodium is not forming precipitate over here, rather it is calcium and magnesium. Acha, technically, is it just the calcium and magnesium which creates problem? Don't we have the problem with the other uh, ions also? Yes, we do have, but fortunately, you can say through the, when how the groundwater storage used to be, right? In rainy season, it will come and layer after layer, it will slowly leach, and it will at the end reach to the whatever the spaces are there to store the water, right? So it passes through so many. So you can say that these are the minerals, calcium and magnesium, whose salts are relatively soluble in water. So that's why it used to slowly from the rock, it used to dissolve in the water. So that creates a problem. Most of the other minerals, salt, they are not too much soluble in water or very less soluble. So their presence is almost negligible, I can say. But yes, if you all want to discuss that, are these two cations only creating the problem? Answer is no. If other dissolved thing will be there like lead also, that will also create the problem. But we are supposed to focus on these two only, right? Now you understood that why we are getting the hardness. Okay. I hope you guys are making notes simultaneously, right? So the reason for the hardness is dissolved calcium and magnesium ion. Very, very important. Ions in water is dissolved calcium causes hardness. All right. Now let us classify the hardness. How many different types of hardness? Types of hardness. And before that, you can, note down all those points which you told at the beginning, that the hard water not only about it, not only it creates problem in cleaning, right, with the soap, it also creates problem in the boiler, right? Hard water creates problem in boiler as well. Why and how? Because when you are heating that, during that phenomena, what happens? The There is a layer of insoluble thing will be deposited on the wall of the container, right? And if it will dissolve, the further heating process and boiling process will become quite slow. So these scale, generally you can say scale, right? Calcus you can say, scale you can say, or the solid deposits you can say, right? They create problem. Right? Deposition of scale causes problem in boiler. Right? Please understand these scales are insoluble precipitates. Right? This extra layer I have shown here. So let's now quickly discuss about the types of hardness. So how many different types of hardness are reported, guys? Two types. Very good. So what are those two? Temporary and permanent. And permanent hardness. Okay, all right. So temporary and permanent hardness. Temporary hardness and permanent hardness. So what is temporary hardness and what is permanent hardness? So temporary hardness means what? Hardness due to, again, calcium and magnesium ion is common now. Now, obviously, alone calcium and magnesium ion can't be there in the solution. It will be definitely there with its negative counterpart also. So if I'll ask you temporary hardness, So what are the set of negative ion that we are expecting here? Due to, yes, anyone? Bicarbonate. Bicarbonate of calcium and magnesium ion. Right? All right. Permanent hardness mainly due to sulfate and chlorides. Right. Calcium plus 2 and Mg plus 2. Again, my dear, it is quite understood that calcium bicarbonate, magnesium bicarbonate, calcium chloride, calcium sulfate, magnesium chloride and magnesium sulfate, these are all soluble things. Do you understand this? These are all soluble things, right? At one point in inorganic chemistry, you will know that aged means if calcium sulfate is left as it is for very long time, then aged calcium sulfate settles at the bottom. But normally calcium sulfate is considered to be soluble in water, right? So calcium sulfate, calcium bicarbonate, calcium, all these are the negative ions. So bicarbonate, why we are saying this to be temporary hardness? They could be simply removed by boiling, can be simply removed by simply removed by heating. Simply removed by heating. So if I'm heating calcium bicarbonate is soluble. If I'm heating it, what will happen? Soluble means, my dear, please understand, it is calcium ion surrounded with water. Bicarbonate again is surrounded with water. Acha, at the same time, I must tell you one more thing, that this bicarbonate, whenever it is present, it will it can convert into carbonate. And in that process, what will happen? The other bicarbonate ion may take that. So basically, this kind of phenomena might take place if you are going to. So one is going to transfer the H plus ion to other, it will become H2CO3, the other will become carbonate. And as you know, this is not stable, right? So if you are heating it, because it is already, my dear, please understand that hardness, when we are speaking about, if you are thinking about that there will be 1 molar or 0.5 molar concentration of the calcium ion and magnesium ion, then you are absolutely wrong. You are doing it blunder. They are present in milligrams, I'm telling you, in 1 liter water. Such a low concentration is there, right? Pathetically low concentration, I'm telling you. So what happens, as I told you, this, if you are going to heat, this bicarbonate is not so much that situation is going to be that bad. But if you are going to heat it, this is how the exchange of proton takes place. And because at heating this will, at this is already not very stable, but if you are heating it, it will break down quickly and you will get CO2. So carbonate you got, and carbonate and calcium combination is not soluble. So what happens? It will form CaCO3, PPT, along with, you can say that this will give you CO2 plus water. This is what you can expect from this. The other important thing is, this is the hint for you to understand. On heating it happens. Okay, so this is hint for you, right? Next thing is, this is really, really important, and here on this particular point there is debate as per two books. One obviously NCERT, the other is Vogel, right? So what is the problem with this? So as per NCERT, my dear, when you are heating this, instead of getting, you know, carbonate as a precipitate, you are going to get magnesium hydroxide. That is very clearly written out there. That is very clearly written out there, that you are going to get the what? Magnesium hydroxide out there. But as per Vogel, my dear, it is reported that if you have bicarbonate of anything, then on heating, it is going to give you magnesium carbonate as a PPT. Again, because in Vogel, the point of hardness discussion is not there. That's a book which is meant for the testing of the cations, different cations and associated test, different anions and associated test. Under that, the carbonate segment, they have given that magnesium bicarbonate, when you heat it, it gives magnesium carbonate, right? But in NCERT, they have given the whole data behind it, that why they are forming this hydroxide, why they are not forming carbonate. So this is an ambiguous thing. Again, if you'll ask my opinion, then I will say to follow NCERT, because it is not something that they committed mistake out here. They have given a proper reason behind it, and that reason is related with uh, the solubility product of these two, MgOH whole twice and the MgCO3 whole twice. Right?
Sir.
Yeah. And if you want to refer those values, if you want to much higher, actually, if you note, I will give you a note over here that KSP, I will tell you what exactly it is. KSP of magnesium carbonate is actually higher than KSP. You can refer the NCERT for this, of magnesium hydroxide. I mean to say that there is high tendency. More KSP means less tendency of precipitation. Less KSP means more tendency of precipitation. Please mind my statement. Okay. You can write it down over here. This is note 1. Note 2. If KSP of a salt is less, then its solubility is low. Now you will be
Sir.
asking, sir, from where we got the hydroxide, right? That might be the doubt. Anything else anyone wanted to ask? Yes, please go ahead.
Sir, sir, how H2CO3 will give H2 and O2, sir?
How?
H2CO3 will give H2O and O2.
Okay, fine. H2O and O2, not, it was CO2, buddy. It was not H2O, it was CO2.
Okay, sir.
You see here CO2 I have written now. There also I wrote it was. Now could you explain that from where we got this, particular thing, this hydroxide portion? How?
From water.
No, the concentration of water is not that great that magnesium can form precipitate with because as I told you that 10 to the power minus 7 molar only we used to get OH minus concentration. That is not so great. This ppm is of the order of 10 to the power minus 6 of the order of that. I mean, yes, you can consider like that. Hmm? Yes, not from water. Anyone?
From H3O to
Hmm? From
HCO3.
how? Very good. Absolutely correct. But tell me how.
Sir, from if we draw Lewis structure of CO3 minus 2 or HCO3 minus, some OH would be bonded.
Oh my God. Are you going to commit that mistake? My God. Never ever think like this. that you are getting OH from this. No, never. Right? We used to get OH from NaOH. The reason is entirely different. There is huge electronegativity gap between sodium and oxygen. Here, carbon and oxygen both are non-metals. You can't expect to break this bond. It is the H plus ion which used to be broken. It is not right. Okay. Absolutely wrong. Okay. That's why we used to say, no, non-metallic oxide and hydroxides. We don't even use the word hydroxide because hydroxide refers to OH minus, which is not present. So,
HCO3 will decompose to CO2.
so
HCO3 will decompose to OH minus plus CO2.
OH minus, how? I can see that HCO3 is decomposing by taking H plus ion from the other bicarbonate and becoming H2CO3, and CO3 minus 2 is produced. Please understand, let me explain. These anions, not only this, my dear, there are many such anions, right? Forget about this. It is even RCOO minus. Even I will tell you that H2PO4 minus. So these anions, which are obtained from relatively weak acids, they can hydrolyze water. Hydrolyzing water means because they are coming from weak acid, so they are not very uh, these negative ions are not very much stable. So they partially, although it is not easy to take the hydrogen from here, but they partially do that. Very less, I can tell you. But yes, this will happen. They will take the H plus ion, become H2CO3, and they releases OH minus. So basically, they are taking this negative ion is taking a proton from here, right? So it is just like that. Please understand, I have shown you here the flow of the electron, right? That these pair of electron is now on the head of oxygen. That's what I mean when I'm showing the arrow like this, right? So we'll be getting H2CO3 and OH minus. So you can see that with this equilibrium, actually we used to get this. Okay, understood, my dear? And then what will happen? Obviously, because you are heating it, so it will decompose into H2O plus CO2. So could you balance this by your own? Write down the other things, but the KSP portion you are going to get this. Because of the KSP, this is happening. Now, fine. In Vogel also it is given, in many book it is given, my dear, that magnesium carbonate, bicarbonate when heated, right? So it will give you MgCO3. At the same time, they have mentioned it that we will be getting hydroxide thing as well along with this. So it is basically basic magnesium carbonate precipitate should be. This is basic, this is carbonate. So this is basic magnesium carbonate. The whole thing is termed as basic. So this is also reported. So be flexible, right? You have to take the call wisely. And specifically, if this particular thing is mentioned, we are supposed to take that. Or if the statement based things are coming, we have to pick up the things. If I have to choose and things are very clear in that, I will be going with this. Because that's the, in case of the conflict, we are supposed to follow NCRT according to me, right? So that's how we are supposed to proceed. Fine, everyone. Let's talk about now permanent hardness. Okay. Now how to remove them? They require proper chemical treatment, right? They can't be removed simply. There are different chemical method. There are different chemical method by which we used to basically, make our water soft, make our water free from dissolved calcium plus 2 and dissolved magnesium plus 2. So can you tell me the different methods if you have read through NCERT?
Washing soda.
Hmm?
Treatment with washing soda.
Fine, that is one of them. Other?
Calgon.
Calgon. What is Calgon, my dear?
Sodium hexametaphosphate.
Sodium hexametaphosphate. Okay. Okay. And other? Very good. Tell me other. Any other method? So till now you told that treatment with sodium carbonate. Other one you told that Calgon.
Ion exchange method.
Ion exchange. Very good. Very good. So could you briefly
Resin.
explain that what happens in ion exchange?
Sodium aluminum hydrated sodium aluminum silicate.
So are
is
you
used
talking
to
about
exchange.
ion exchanger resin? This one you're talking about? Hmm?
No, sir, ion exchange.
In ion exchange, there are two things. One is the treatment with zeolite. The other treatment is with ion exchanger resins. So right now, which one you are talking about? Ion exchange through zeolite or ion exchange through resin?
Both are different methods.
Both are, sorry, both are same or different? Okay, all right, no issue. Any other student? Can you tell me the formula of washing soda
Na to C.
Into CO3.
and baking soda?
NaHCO3.
Do you ever get any confusion in these two? Baking and that? Bicarbonate on heat treatment produces CO2 gas. So that helps in baking bread also, right? But carbonate, on the other hand, specifically of sodium, I will tell you this thing that sodium bicarbonate, if you are heating, it will produce CO2, right? Right, CO2 it will produce, which helps in baking. Whereas if the carbonate of sodium is there, if you are heating, it requires very, very high temperature. Otherwise, you will not get anything. Basically, there is high tendency of ionic character over here. You remember I told you, except lithium, the remaining alkali metals have extremely poor polarizing power. So if anything is happening out there is because of anion, not because of cation. Whereas lithium, beryllium plus 2, magnesium, calcium, barium, zinc, except these cations, the behavior of most of them are different in terms of polarizing power. I will show you the consequence of that. Okay, I will show you. Don't worry. So that's what I was telling you. That baking soda means sodium bicarbonate, and washing soda is. So which one are we going to use for cleaning? Which one are we going to use to remove the hardness? Hmm? Baking or washing?
Washing.
Washing.
By washing soda. Sodium carbonate. Okay. The next thing. Second, as you guys rightly told, Calvin. Third, tell me, zeolite. Zeolite or permutate, right? My spelling might be wrong. Zeolite or permitted. The fourth one is resins by ion exchanger. Resin, specifically resin. This is also a part of ion exchanger, right? Ion exchanger zeolite, and this is also ion exchanger resin. Resins. Okay, this is really interesting to know that. All right. Any other method to remove the, apart from heating, do we have any other method which can remove the temporary hardness? Have you ever heard about Clark's process?
Clark.
Huh? Have you ever heard about Clark's process? I will tell you that. Can also be used to remove temporary hardness. Right? Okay. So what is Clark's process? I will come one by one to the permanent hardness. Let's first finish this. What is Clark's process? Tell me.
We'll add lime.
We'll add
Lime.
lime. Thick lime, lime. Anyway, sir. So, sir, you have already taken water, right? So calcium bicarbonate is there. And if you are adding lime in water, it will become calcium hydroxide. Isn't it?
Yes, sir.
So technically it has become lime water now. This is also aqueous, means soluble, and this is also aqueous, means soluble, right? Soluble in water. So what it is going to produce? Very simple. So the hint is that this bicarbonate is acidic in nature, isn't it? Very interestingly, this bicarbonate have H plus ion. Never break OH, but you can break H plus. And with OH minus, this can react, and OH or H plus will form water, and it will produce carbonate. And carbonate of calcium is insoluble, my dear. CaCO3 will become insoluble. You understood my point? Yes or no? And you're going to get water, 2H2O. Please balance this. 2H2O is there. This is precipitate. Right? So basically you can say acidic hydrogen. All right, my dear. So this is how really. But there is a problem in Clark's process. What? What is that problem? Can you see the problem? I can see it very. See, our role is
Sir,
to
if we
remove
add,
We have to filter.
what? Are Baba. Okay, filtration will be there. That is not a problem actually. The problem
sir,
here
if we
is,
add more,
right. You say completely. You complete your statement.
if we add more, it will convert to permanent hardness.
You see, our whole role is to remove calcium ion, isn't it? And now you see the raw material which we are adding here. What we are adding here? Calcium itself straight away. So if your calculation is right, then this is wonderful. But suppose if you are adding more accidentally, you did not calculate it proper, then what will happen? That it will itself create hardness. You wanted to remove hardness, now you created by your own. So please make a note. Very important. Very important. Only calculated amount. Otherwise, extra calcium hydroxide will itself cause hardness. Okay. So this is it about the temporary. Now let's talk about the permanent hardness by washing soda. Again, if you look at the whole process is roaming around to get the precipitate of the calcium or magnesium out from the mixture, isn't it? The whole thing is roaming just anyhow to get this calcium out by making them precipitate. Other methods are also there, my dear. Like even EDTA is also used for estimating hardness, right? I will tell that also, which is really, really important for us. But for now, tell me how we are going to use the first method. That means by washing soda. Okay. Yes. So by washing soda. Tell me. Tell me how we are going to use it. The calcium, either it is chloride, it is aqueous, means soluble. So if you are going to use Na2CO3, what will happen? Tell me. Tell me, Baba. Guys, am I audible?
Sir, carbonates will.
Yes. So you see everywhere. You see from the beginning, right? If you observe reaction, you can easily memorize. I'm telling you. Carbonate is insoluble. If you have just one point, you can answer many of this. Carbonate of calcium, you can see here. And here also, the primary role is to convert into carbonate. CaCO3 precipitated out. And you enjoy with NaCl. There is no problem. You can balance the reaction by your own. To NaCl. Tell me, in this process, if accidentally we are using more sodium carbonate, will it create a problem? Answer is no, sir. Because calcium is removed, no, sir. And sodium is not creating any problem there. Yes or no? Okay. In this process, calcium carbonate is precipitated out. CaCO3 is precipitated out. right? So this was by washing soda. Now let's talk about the Calgon process.
Sir, can we use in this process NaOH also?
NaOH, if you are going to use, then what will happen? That NaOH, if you are going instead of this one, if you are going to use NaOH, that's what you are saying, na? If instead of taking calcium
sir.
carbon. So tell me, calcium hydroxide is soluble or insoluble? Tell me by yourself. Yesterday I spoke about it already. Good. I really loved it because the way you are trying to analyze, very good. But tell me, calcium hydroxide is insoluble or soluble? You remember I told you in all S block member of S block member, the insoluble oxide and hydroxide is beryllium. Magnesium hydroxide is sparingly soluble, except that this, what to say, the calcium hydroxide, barium and strontium, they are all soluble. You remember that?
Yes, sir.
Yes, sir.
So if it is soluble, then again the whole treatment is pointless now. Because if you are making it soluble, again the calcium ion is present now within the water. I need to anyhow either engage it to some other thing, even if it is present, it should not combine with the soap and the other thing, or it should be removed. That would always be better, right? So by washing soda you have seen, and now I think space problem will be there. So I'm just going to switch over here. The next thing is Calgon process. So what is Calgon process? So you know Calgon is a name given to sodium hexametaphosphate. Na metaphosphate, my dear. Metaphosphate is HPO3. Are you getting my point? The general representation. This is Calgon. This is sodium hexametaphosphate. Wait a minute. Wait a minute. Sorry. H will not be there. Extremely sorry. Right? Metaphosphate. So let me tell you that this is phosphate. Normal phosphate is this, which is coming from S3PO4. Metaphosphate is this. The structure of phosphate is very simple. But metaphosphate structure is complicated. Mostly polymeric. Trimeric is also there. Trimeric, hexameric, but mostly polymeric, I'm telling you. Metaphosphate. It is not so simple. Right? This is phosphate. But phosphate is very simple. So please understand there is just one unit charge. Right? So you can understand the structure might be like this. I'm just showing you the part of it, my dear. It could be even trimeric also, but I'm just showing you. So why it is PO4, sorry, PO3 minus, you can see that repeating unit of this can create this structure, right? So this unit contains 1 phosphorus, 3 oxygen with 1 negative charge. Understood, na? Yes or no?
Yes, sir.
Okay, so dot 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 polymeric is also there. As I told you, it could be even trimeric also, depends. But the actual, this is a very common representation of this. 6 sodium, 6 PO3 minus. It seems that there are 6 PO3 minus 6, but it is not like that, right? It is not like that. The actual representation of Calgon, can anyone tell?
Na6P6O8.
Hmm? That is even weird.
Sir, Na2, Na4, PO3 taken 6 times.
The right answer is yes, please go ahead. Once again, you tell me. Na?
Sir, Na taken twice, sir.
Very good. Within box.
Na4, yes, sir. Na4,
Then
PO4,
PO3,
PO3,
na?
PO3, PO3 taken 6 times.
This is how it is represented. So now what happens? How we are going to treat this? If you are interested in this metaphosphate, in which way it is, you can, I guess, you can understand this thing. Can't you? Can't you understand this thing that 6 PO3 units are there? Means definitely it will be a cyclic molecule containing 6. So what I did, I was showing you the most common one, metaphosphate. Please make a note that it is not necessary that it will exist in this way. Many forms are there. Structure is complicated. Mostly you can say the word which I have written, trimeric, hexameric, polymeric. You can write like that, so that otherwise you will think that only polymeric structure is there, right? Trimeric. It could be even tetrameric, hexameric, polymeric. कुछ भी हो सकता है, right? It could be anything. So by just looking at this hexametaphosphate, and if it is a unit, which clearly means that it is having a structure which is having hexameric. But again, the structural thing has never been asked, and it is not given clearly in NCERT for this. We have a description of metaphosphoric acid, trimetaphosphoric acid, tetrametaphosphoric acid. These discussions are there in P block of nitrogen family member, right? So let's talk about this, that how it is going to remove that. Yes, anyone, any idea how it is going to function? Hmm? Yes. Fine. All right. Guys, am I audible, right?
Yes, sir.
This is the polymeric I have shown you. This is trimeric. If you are willing, you can draw it. Check it out how many members are there. POP, 3 OP, trimeric form. Check the valency, 5 should be there. This is one form, right? The other form you can draw like that, 6 phosphorus, 3, 4, 5 and 6. Accordingly, you can draw POP, POP, POP. Sorry. Yes. And now you put a double bond out there everywhere. Put a double bond out there. Then put O minus. This is, you can say that this anion is what I was talking to you about. So you can see the unit again is same, PO, double bond O and O, just one negative and this PO3 minus. All right. See, the metaphosphate is existing in polymeric. Now I have a very valid point to ask you, whereas nitrate ion exists like this. So why is it so? Why is it so that nitrate is having monomeric unit, whereas the phosphate PO3 minus is known as metaphosphate, and that does not exist in this form? Can you quote the reason? Now you can answer, you know. I have equipped you with the sufficient tool. You can answer it. Tell me.
Nitrogen can't be pentavalent.
Okay, fine. I'm not asking about nitrogen, right? I'm asking about why can't PO3 minus exist the way nitrogen NO3 minus is existing. At least phosphorus have the choice, na? What's the problem with the phosphorus? Nitrogen don't have choice to go in that way. Agreed. It won't be pentavalent. But why can't this phosphorus adopt this structure the way nitrate ion is reported?
Sir, phosphorus cannot give lone pair easily.
Hmm. What are you talking about? Are you aware that phosphorus is R3P is better nucleophile than NH3, NR3? Better electron donor, quick electron donor. It is difference is NH3 and PS3. Their PS3 is poor because of not participating in hybridization. So lone pair is present in s orbital, difficult to donate. But in case of PR3, 3R group, alkyl groups are there, then it is sp3 hybridized. It is better donor, not okay. Kinetically, it is much better, faster also. Yes, you think about it. You have the reason I'm telling you. See, I told you the way inorganic is looked at, that it is a topic where you have to simply mug it up. It is not like that, guys. If you'll start giving a logic now, you will find it really interesting, right? So tell me.
Sir, PO3 is more covalent than NO3, so it undergoes dimerization.
Where is it written that covalent molecule undergo dimerization, my dear? CH4 is extremely covalent. Will it undergo dimerization? F2 is 100% covalent. Will it form F4? Again, that's not a valid reason. And cross question yourself also, right? The cross question, more you will create, more you will have a out of multiple possibility, few will be rejected by your cross question itself.
Sir, because p-pi between second and third period is not as effective.
Well done. You see, one student from you is popping up and telling this answer. This was expected from all of you. Very good. What's your name, dear?
Snigdha.
Snigdha. Very good. You have to look in that way, yaar. Second period element and third period element, if you are comparing the chemistry, the first thing that you should be really concerned of is about the effectivity of the pi bond. In phosphate, that bond, pi bond is p pi d pi, whereas in nitrate that is p pi, and because the third period onward p pi is not effective, We cannot. So the P pi effectivity which you use only for N2P2, for O2S2, is it limited there only? No, only those are the examples which I told you in the past. You can generalize this point to the whole chemistry. So that is something which I'm expecting from all of you, right? Okay. Unfortunately, this much liberty will not be there to discuss about these topics so deeply, because mostly I will tell you, apart from your batch, the other batches, what generally we are expected to do is just introduce Calgon. What is it? Not going into the deep of that metaphosphate structure also. I am just deliberately, giving you these things so that you can think that, okay, these are the possible ways, and at the same time I'm raising these questions deliberately. So anything which is under your domain, I will definitely ask, my dear. So whatever you have studied, I'm going to drill every time. Okay, next time if I'll be there in boron family, if any application of the S block or hydrogen will be there, I'm going to re-ask the question. Be prepared. That's what I'm trying to tell you. Keep on revising the thing, keep on revising the inorganic chemistry. More you will revise, more crystal clarity you will get, that how to think, how to attack. Okay, anyway, and I told you that chemical bonding is the backbone. Chemical bonding, coordination, periodic properties, and atomic, they are the backbone of the whole chemistry, right? So you have to have a proper clarity. Otherwise, what will happen here and there, whatever the logic you are going to fit into, and you're not cross questioning yourself, then you will end up having, lack of interest in this. Okay, fine, everyone. So yes, let's talk about how it is going to react, guys. The process, the chemical process, the calcium ion or the magnesium ion. Right, so I am going to write as M. So this, wait, M plus 2. It could be calcium or magnesium. Tell me, if I am taking Na2, Na4, tell me, PO3 whole 6. You know what happens at the end? What happens if I'm not telling you that much about metaphosphate? Some people at the exam, they get confused and yaar, what is metaphosphate? They used to think that might be something wrong. This is something correct. PO4 minus 3. That's why I told you all this, to stabilize these points into your brain. That phosphate is this. Metaphosphate is this whole thing. Anything. All of them are metaphosphate. So that you should have a very clear picture. No, metaphosphate is entirely different. We are not supposed to get any kind of confusion, right? Most of the student used to complain, sir, got confused in the point. Sir, didn't have the, I thought that this is this is that. How these confusions will go away? If you'll analyze the thing more and more deeply, then confusion will not be there. The problem is just one reaction you are thinking and you're not thinking beyond that. So the whole problem starts from there only. Okay. So my dear, what it is going to form? It is going to form Na2. If it is going to replace this whole, what to say, the whole of these sodium from here, it will be calcium. If it is there, it will be twice. Otherwise, mostly if the amount is more of this calgon, then they generally replace 2 sodium because they are having +2 charge now. So inside for charge balancing, they'll bring. So it will be M, right? And Na2, you can write Na first, it's up to you. PO3 whole 6. Again, you know what is M here? Either calcium or magnesium ion. Now the next question is, now as it is the method to remove the permanent hardness, means removal of calcium. Is it removed? Is it removed? Answer is, sir, earlier it was free, but now it is trapped inside the complex. Earlier it was free. You know, calcium phosphate is a very strong precipitate, strong in the sense I'm trying to tell you that you cannot dissolve it so easily. And I must tell you that the calcium phosphate along with calcium fluoride or calcium hydroxide, this is the composition of our enamel. You know that? Teeth is made up of this phosphate only. It is, if it is soluble, you see, we used to eat the drink which are slightly acidic also. We used to drink something which is slightly basic also. We used to expose our teeth with the heat also. Water we are constantly drinking, right? Throughout the day so many times. Imagine that if calcium phosphate is soluble, what will happen? Okay. Just a glass of water and your teeth are gone. So it is not like that. So calcium phosphate is insoluble. So you can understand that you have tried to trap the whole thing over here. The metal is strongly bonding, making a bond with phosphate, this metaphosphate. So you cannot remove it easily. So even if it is there, it is not going to interfere with the acid. That one, it is not going to interfere with that. Okay. So our problem is actually solved. All right. So please mind this. This is really, really important. So here you can say example that Na2 calcium Na2 PO3 whole 6. Similarly, you can say that if it is magnesium, it will be Mg Na2 PO3 whole 6. My dear, you know that na, everywhere you saw the case of sodium carbonate. There also the calcium is replacing. Calcium ion is replacing that. So you can understand calcium is having a better hold of the oxygens. I mean, that is having a better hold on oxygen than sodium, because sodium is having very less polarizing power. Sodium, potassium, rubidium, cesium. Calcium has having better. Okay. Fine, everyone. So this was the which process? Calgon. Now let's talk about ion exchangers. Ion exchangers. Tell me about this ion exchangers. Hmm? So under that, the first thing is using zeolite. Guys, am I audible?
Yes, sir.
What is zeolite, you tell me? What is zeolite? Hmm? Tell me, any idea? Okay, you might not be aware with the word silicates. Okay, so this is sodium aluminosilicate, zeolite. It is not one compound. Series of compounds are there, right? zeolites are sodium aluminosilicate. Sodium so what is that? Hmm? What is that? So if you simply represent the representation, that is Na2Al, yes, to Si2O8. But again, as you have seen that in case of phosphate, metaphosphate, there also we had a problem that it is not existing in the simple unit. P double bond O, double bond O, and O minus. It's not existing like that. Like that, even silicates also. You remember I told you about silica? I told you that CO2 is monomeric, whereas SiO2 is not monomeric. It is a three-dimensional crystal. You remember that? Guys,
Yes, sir.
Yes.
Anna? So there I told you SiO, 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 it will keep on going like that. So silicates are these things only. If you're going to just simply cut it down like this, then it is SiO4 minus 4, which is said to be orthosilicate. Like the 2 unit of that in between oxygen, it is said to be pyrosilicate. Understood, na? Okay. So orthosilicate, pyrosilicate, like that, there are polymeric also in nature, linear polymer, SiO, SiO, it will go on like that. O minus, O minus, O minus, O minus, O minus, O minus. It will go on like that. So as I told you, silicate is not one thing, it is a class of the anion. Silicates are class of the oxoanions of silicon. Please make a note that it is not one molecule or one ion. Understood, na? Okay. So is a sodium aluminosilicate, which is represented by this. The main composition we are supposed to look at is this. Please make a note that silicate is a class of oxyanions of silicon. It could be anything, my dear, ortho. So there are many, but here, and again, I will tell you that this particular silicate in that class also, it comes under three-dimensional silicate. Okay, because sometimes the question in class 12th will be asked silicate. Don't worry, this is there in class 11th only. Okay, once we'll enter into carbon family, there we'll study deeply about the silicate. Okay, if you are interested, I will forward you a notes of this silicate. This is quite big. Even the students of class 12, those who are going to write the exam, they are also scared of this topic. How to figure out the formula, right? The here things are written like this. You have to you're supposed to remember it like this. Si2O8, 3D silicate or three-dimensional silicate. So what can we expect in this? So what is going to happen with this? So basically, my dear, it is a solid, right? You can see that it will be a solid. Suppose you have that silicate over here. The whole solid is over here. It's not liquid, okay? Sorry. Please suppose this silicate is out there and you are pouring water here, which contains calcium and magnesium ion. So what will happen, you tell me? So if suppose you are taking out the water over here, In this case, the calcium will be settled here and sodium will come instead. So basically it exchanges its sodium ion with the calcium and magnesium. Right. So mainly there is exchange of sodium ion with calcium and magnesium. While treating water, hard water, with zeolite, there is exchange of sodium ion with calcium and magnesium. So what happens if you want to represent it like that? You are supposed to represent in this way. That Na2 Al2 Si2O8 plus calcium ion, you can replace the sodium out there, right? CaAl2. Again, it depends, right? So calcium is going to replace, but so basically the calcium and sodium is going to exchange. So Na plus you will get instead of that, right? This is how you can expect that, but I think writing this is enough. Now, good thing about this could be regenerated. This after some time, because the sodium ion, after the exchange of that, it will be of no use, right? Because now sodium is not there. But the zeolite can be regenerated, recycled. After removing hardness, it could be recycled. Zeolite, after hard water treatment, it could be regenerated by treating with brine, you can say, or the cheapest source is seawater. Like seawater. Best source is that. Okay, so again the calcium ion will be replaced by the sodium, because the one which is excess, that is going to take part out there. Okay, so this was the thing related with this. Ion exchanger, I will show you. You are supposed to copy here because it will take time to draw the diagram. Let me check if it is already there in ready-made form. Yeah. Okay, here are the values I have written. If you are interested, you can copy straight away. Take a screenshot, copy it later. Okay. The values of the KSP of magnesium carbonate, hydroxide, values I have written. You can write it down. You can see that out of carbonate and hydroxide, it is less soluble. Out of carbonate of calcium and hydroxide, it is less soluble. That's why CO3 PPT we used to get, right? So you can copy that. Okay. So I was interested to tell you about this. Yeah, this is the resins, my dear. Okay. So let me just roughly brief you and thereafter I'll copy you. What are resins, my dear? Cation and anion exchanger resins. What are resins? What are resins? So resin contains basically either acidic group or basic group, organic acid or organic bases. Organic acid, when I'm talking about, we have the derivative of phenol, we have the derivative of sulfur containing thing, we have the derivative of carboxylic acid, right? We have the derivative of uh, sulfur containing thing. So all of these are organic. So the this is said to be cation exchanger resin. What happens that if you are putting water in this resin, the calcium ion and magnesium ion are going to replace these H plus ion from here because they are acid anyway. So you inside water you will get H plus ion, and the cations, not only calcium, magnesium, my dear, sodium ion, any for that matter, any ion will come, positive ion will come and get exchanged. And this is cation exchanger. In anion exchanger, we are having long chain molecule with the basic group like NH2. With water, it will be NH3OH, right? You can take many other basic group. So there what happens, your negative ions like sulfate ion, chloride ion, bicarbonate ion, right? Any negative ion is going to exchange with them, and you are going to get in return in the water as OH minus. So now so many questions are asked. First question is, if I'm treating first with a cation exchanger, the nature of solution will be, tell me which type of solution you will get, acidic, basic, neutral. Guys, come on. Am I audible?
Yes, sir.
So please tell me the answer. That if you are treating first with the cation exchanger, the solution which you will obtain after that, will it be acidic, basic, or neutral? Acidic. Because you exchange all the cation and you got H plus ion. No, suppose you are first treating with the anion exchanger. In that case, what will be the nature of that solution? Huh? Basic. But if you are treating number one, and then number two here, and at the end, if you are interested, what will be the nature of solution?
Neutral.
Neutral. And you know, this water which we used to obtain is pure water. There is no ion, free from any ion. So this particular resin exchange through the resins can remove all the ions, metallic, non-metallic ions, right? So instead of that, they will give you H plus OH, which will combine and give you water, proper water. Okay, so please make a note on this, cation exchangers. Note it down.
1 minute.
1 minute.
Please.
These are just diagrammatic representation. Please understand the actual way of treatment might be different, but the chemistry associated with that I'm trying to tell you with the help of these diagrams. Okay. So cation exchanger, as I told you, it consists of acidic groups and it exchanges cation present in water with H plus ion. Right? That's why if hard water is passed through the cation exchanger resin first, then it becomes acidic in nature. That's what I have written over here. But please make sure the word first is attached, only first. just by treatment with that. Quickly make a note. Done? Over? Fine. Please go ahead quickly. Okay, guys, done? Fine. So I already told you about all this. And now let's have a discussion on calculation of the hardness, right? How to calculate it. Means, so first of all, as I told you at the very beginning, okay, just listen right now. Stop writing. I will share you the notes. Stop writing on this. Please understand. This is the part of physical chemistry now. Please understand. So how to calculate hardness? The calculation of hardness is done in many ways. One of the most popular ways is representation in terms of calcium carbonate, right? And as I told you, that the amount of these dissolved minerals will be very, very less, few milligrams that in 1 liter. You can understand, not even in gram, milligram, I'm telling you. Okay, so that low it is, and that's why for such a lower concentration, we use the word ppm, parts per million concentration. ppb, parts per billion concentration. So parts per million and parts per billion. I hope you are already aware with these terminologies. Here I am going to just hardness in terms of calcium carbonate. I'm telling you. So how it is written. So hardness expression is, don't write anything, just listen. Please guys, please listen. Hardness, am I audible guys?
Yes, sir.
Okay. So hardness is reported like this, that mass of CaCO3 equivalent to magnesium, calcium ions, right? I will tell you the meaning of that, and divided by mass of the solution into 10 to the power 6. When I'm saying mass of the solution, solution is a combination of solute and solvent. But sir, you can see that the amount of solute is so poor that here instead of saying solution, you can simply say that mass of solvent means mass of water. Right? Into 10 to the power 6 million means 10 to the power 6. When I'm talking about ppb, then it will be, so hardness is calculated in ppm. Okay. Now what is the meaning of this? The meaning of this is, suppose you are having few milligrams of calcium plus 2, and that is present in various sources like calcium sulfate, some calcium bicarbonate is also there, and some calcium chloride is also there. Then how much, while treatment, how much, suppose if I am treating them with carbonate ion, how much milligrams of calcium carbonate I am going to get? So basically it is associated with that, and this is generalized for even magnesium also. So assume that instead of magnesium we have calcium. So how to proceed then? So very simple here. Whatever the number of moles of calcium ion over here is there, same number of mole of calcium carbonate will be obtained. So basically what you have to do, you have to take the number of mole of each component present, and sum of all these mole, whatever the component A, B and C is there, sum of all these, you have to assume that same number of mole of calcium carbonate is there. And if you know the mole, you multiply with 100, you will get the mass, isn't it? Calcium carbonate molar mass is 100, yes or no? Formula mass is 100, yes or no? 40 for calcium, 60 for carbonate. So total you will get. So this will give you the mass. And that's how we used to calculate. I'll show you one example so that you can start practice on this, right? And this will be the last thing for today. So mass equivalent calcium carbonate we are assuming. So how I'm doing? So I have suppose given an example of, suppose you have 200 ml sample of water which consists 111 milligram of calcium and magnesium this and this much, and then calculate the hardness in terms of calcium carbonate. Right. So you can actually change this by taking calcium sources only, calcium chloride, calcium sulfate, and calcium bicarbonate. So essentially what did I do? As I told you, I'm calculating the mole of every single component which is present, and I'm just adding them and equalizing with the calcium carbonate mole that we are going to get in future, right? So calcium carbonate mole is known, then simply mass means you multiply with 100. Then what? Nothing is there. Hardness is equal to mass of COCO3 upon mass of solution 10 to the power 6. That's how the calculation I have made. That's how you are supposed to do. And if they are asking in other terms, then you have to follow that. But if you are not this, if you're they're simply asking us to calculate, sometimes you have to look at the unit also. Here I told you in terms of, as I told you, various methods are there. So this is the one which is most popular, I told you, right? So if you'll do the question, you will get an idea that how you have to proceed. So that's all everyone for today's lecture, right?
Once can you scroll up?
What do you want? You want to write this formula and everything?
No, sir. Once I'll check problem. Can you scroll down?
I don't think that I should give you time on this because I told you, you understood it also. You should apply and learn. Okay. If I'll tell you, then the whole point of telling this thing will be waste, I guess. So you apply directly and learn. I told you the essence that how you have to do, right? The concept is you have to take the all component and assume that if they are going to convert into calcium carbonate, how much mass I'm going to get. So I told you simply equate their mole and then accordingly proceed. The formula of ppm you are already aware with. So why should I expose you with the example, right? You directly calculate, na? These things are practiced for the student who are, you know, just coming up from CBSE background from class 10th and don't have any idea. So for them, these things are okay. For you guys, I won't show you. You do it and I will meet in the doubt session, right? So that's it. That's it, guys. That's it for today's class. You please go ahead with the practice. Practice.